we are given the expression y equals to sine inverse x whole square, and we need to prove this whole expression. To now we are given now moving forward to the solution. First we need to look at how to differentiate a uv function n times. This is very simple. By using this formula, that to differentiate a u dot v function, that is product of two function n times, we can directly write it as nc0 differentiate u n times, keep b as it is, plus nc1 differentiate u n minus 1 times, and differentiate v one time, plus nc2 differentiate u into u n minus 2 times, and differentiate v 2 times. This will follow this is like the binomial expansion, and we will expand it up to which the v function become a constant. Okay, now moving to the solution. Y equals to sine inverse x whole square. Now differentiating this expression with respect to x, we get y1 equals to 2 into sine inverse x root over 1 minus x square. That is we have applied as chain rule. This is simple differentiation. Now taking this y minus root over 1 minus x square to left hand side, we get y1 into root over 1 minus x square equals to 2 sine inverse x. Okay, now differentiating with respect to x, we get we will apply here the chain rule, that is keep y1 as it is, and differentiate root over 1 minus x square, that is x by root over 1 minus x square, and then keep root over 1 minus x square as it is, and differentiate y1, that is y2, equals to differentiation of 2 sine inverse x, that is 2 by root over 1 minus x square. Now taking root over 1 minus x square LCM, we will get this expression, that is y2 into 1 minus x square minus x into y1 equals to 2 into root over 1 minus x square. We have taken this whole root over 1 minus x square, that is LCM 1, to the right hand side and multiplied here. Therefore we will finally get y2 into 1 minus x square minus x into y1 equals to 2. Now we will apply the theorem that we have learned here, how to differentiate a uv function. There first, moving forward to this, we will take each term of this expression one by one. First we will take y2 into 1 minus x square, that is, now first take it as u and take it as v. Okay, now first we will write nc0 into y, differentiate y2 n times, we will get nc0 y n plus 2, and keeping v as it is, that is same 1 minus x square, plus nc1 into differentiate y2 n minus 1 time, that is y n plus 1, and differentiating v 1 time, that is differentiation of 1 minus x square, that is minus 2. Now nc2 plus differentiating y2 n minus 2 time, we will get yn, plus differentiating 1 minus x square n minus 1 time, that is differentiating second time, we will get differentiation of minus 2x as minus 2. Okay, now we have got here a constant, so we need to stop here only. Therefore simplifying this, we will get nc0, it is 1 1 into y n plus 2 into 1 minus x square minus 2 nc1 is n, that is minus 2n y n plus 1 x into y n plus 1 minus nc2 is n into n minus 1 by 2, that is n into n minus 1 by 2 into yn, and 2 to get cancelled. Finally we will get yn plus 2 into 1 minus x square minus 2nx into yn plus 1 minus n into n square plus n into n minus 1, that is n into n square minus minus plus n into yn. Okay, now taking the second expression in this, that is x into y1. Taking x into y1, that is x into y1, take it as u and take it as it as b. Now differentiating n times, we get nc0 differentiating y1 n times, that is yn plus 1, keeping v as it is, that is x as it is, that is x, plus nc1 differentiating yn minus 1 time, that is yn, into differentiation of x 1 time, that is 1. We get here a constant, therefore we need to stop only here. Therefore we will get nc0 that is 1, we will get yn plus 1x plus nc1 that is n, that is yn. Okay, now combining the combining the results that we get, that is differentiation of y2 into 1 minus x square n times minus differentiation of x into y1 n times. Combining them, we can write, simply writing them all together, we will get y2 yn plus 2 into 1 minus x square minus 2n x into yn plus 1 minus 2n n square plus n into 1 plus n into yn minus yn plus 1x minus n into minus. Therefore n into yn plus and n into yn minus get cancelled, and simplifying and taking now taking n plus 1 common, that is n plus yn plus 1 common. Make it simple, to make it simple, take y n plus 1 common. Therefore we will y n plus 2 into 1 minus x square as it is, and taking x into y n plus 1 common, we get minus 2n, that is minus 2n, and minus 1, that is minus 1. Taking minus, we can write it as it is. Therefore 2n minus 1 x into 1 x into 1 plus 1 minus this function as it is, that is y nx n yn into n square equals to 0. That we need to prove. The expression we have that we need to prove. Okay, hence proved. What we need to learn in this question is that how to differentiate a function, a product function n times. Once again I am repeating it, that first we take first we write and this is like how we are opening the binomial expansion. First we write nc0, then un differentiating un times plus v0. Notice that the sum of this and this will always be n. Sum of n, so the sum of the how many times we are differentiating u function and how many times we are differentiating v function, their sum will be always equals to n. Therefore nc0 un v0 plus nc1 un minus 1 then v1 summation n minus 1 plus 1, it is n, will get n. nc2 un minus 2, therefore v2 combining this to get, we will get n. We will follow this up to when we will get v function as a constant. And some basic things are nc0 equals to 1, nc1 equals to n, and we can write nc2 as n into n minus 1 by 2. Like we can write 4c3 as 4 into 3 into 2 by 3 into 2 into 1. Similarly nc2, that is nc2, we can write n into n minus 1 by 2 into 1, that is n into n minus 1 by 2. These are the basic thing. I hope you all know this. Therefore we will simply prove this expression. Thank you for watching.